And what's an example? How does it work?
Will, let him know. Yeah, Professor Will.
Dr. Will.
Oh, that's on my section.
Yeah, we're on your section. We're on Newton's law of cooling.
All right. So it's the rate of cooling of an object by conduction, convection, or radiation, and it's proportional to the temperature at delta T between objects and its surroundings. So it basically warms and cools up objects within its surroundings.
Yeah. So it talks about the rate at which things heat up or cool down. So it's the rate at which objects heat up or cool down. It's called Newton's law of cooling, but it works for heating too. Objects heat up or cool down is dependent on the temperature difference between the object and its surroundings. Okay, so if I want to cool something off, so I have an apple pie. Nope, I can't draw an apple pie very. I have a cup of coffee. I can draw a cup of coffee, absolutely. There we go. And I need my cup of coffee to go from way too hot, which is 212 degrees Fahrenheit. That's a hot cup of coffee. And I needed to go to something more realistic, like maybe, I don't know, like 100 degrees Fahrenheit. So it's just little wispy heat going on there. How could I cool this off the fastest? What could I do? Eric. Put it in the freezer. Yes. If I want to do this, what I can do is I can put it in the freezer. Because the temperature difference between the coffee and the freezer is large. Therefore, it will cool at a faster rate than if I just left it on the counter. If I just leave it on the counter, will it cool off? Yes, the counter is colder than what the coffee is. But it won't cool off as fast as if you put it in the freezer. Something else to make mention of. If you were to graph this as how long it takes based off of the temperature difference. Yes. It's like this. So it cools, when the temperature difference is large, it cools very, very quickly. But as that temperature difference shrinks, the time is it'll take longer to cool off, right? So if I put it in the freezer, it'll cool off really quickly until but eventually it'll have what's called diminishing returns. It won't be as large of a temperature difference, and so therefore it won't cool as fast. So it's not a linear regression. It's an exponential curve. Okay? Sweet.